So this is a summary of the representations of methane. So methane, we know, is the chemical name. And we can show the chemical formula. Doesn't show how the atoms are bonded, it just shows the atoms and how many. The atoms as element symbols and how many as subscripts. This is the structural formula, and that's also called the Lewis structure. So that is how the atoms are bonded together, and the Lewis structure specifically shows the atoms, the bonds, and also, if there are any present, there are not any present in this structure, any lone pairs. Okay, so we'll get to some lone pairs in the next slide, but this is the VSEPR shape, is the three-dimensional shape of the molecule, so moving into 3D, and this was the tetrahedral shape that we just saw. That was the tripod. It is a base of 3. 1, 2, 3 hydrogens on the bottom. One's coming out front and one's going out back. And then there's a tall top. This is a tall pyramid. We'll see another molecule shape that is a low pyramid without the tall top. And then this is called the space-filling model or the molecular view. We've been looking at a lot of these molecular views in these chapters. And this is the molecular view where we have carbon is this black molecule, or the black atom, and then there are 4 hydrogens. Those are indicated as white, and they're all smushed together. So that's a molecule. Lone pairs of electrons factor in when determining the VSEPR shape, the molecule shape, because we're looking at how many bonds and how many lone pairs to determine the VSEPR shape. So the VSEPR theory is the molecule shape, that's the three-dimensional molecule shape, is determined by how many bonds and lone pairs on the central atom. So for the methane molecule, there were no lone pairs on the central atom. There were just 4 single bonds. But this is a molecule that's ammonia, which is NH3. This is the Lewis structure of ammonia, and this is showing the atoms and how they're bonded. So this is the Lewis structure of NH3 down here, and this is 2 versions of it. So we can show the nitrogen has 8 valence electrons around here, if you count the lone pair, and then there's 2, 4, 6, and 8 electrons around that nitrogen. And then switching colors, each hydrogen atom has 2 electrons. So this has 2 electrons in that bond, 2 electrons in this bond. These are all in green. And 2 electrons in this bond. Okay, and so because the circles are overlapping, what that means is not just a big mess, but the overlapping circles indicate that these are shared electrons, and those are covalent bonds. Okay, so that is the process of writing the Lewis structure, but then we take the Lewis structure and then determine the VSEPR shape by looking at how many bonds and how many lone pairs are on that central atom. So when determining the VSEPR shape, you go back to the Lewis structure. So I cleared the screen. And using the Lewis structure, you look at the central atom and how many bonds and lone pairs are on that central atom. So this is the central atom in orange, and you can see that this has 1, 2, 3 bonds. So there are 3 bonds, and there's also 1 lone pair. So that 1 lone pair is those 2 dots above there. So 3 bonds and 1 lone pair, and that's the recipe for what's called a trigonal pyramid. That is similar to the tetrahedral tripod, but this is what I mentioned that would be a low pyramid. This only has a base of 3 and no tall top. So this is the VSEPR shape. It's called the Trigonal Pyramid. This is here. And in 3 dimensions, you have the central atom, that's the nitrogen. There's one bond that you would consider just in the plane, directly across from it. There's one bond coming out front, just like tetrahedral. And then there's this bond that's dashed, and this is going out back, just like tetrahedral. So this is the molecular view, or the space-filling model. And this is the truest version of this molecule. And so you can see there's a base of 3 hydrogen atoms, and then a center atom. This is the nitrogen. And this is no tall top. So the reason why is because there's a lone pair of electrons that pushes down this lone pair of electrons in green. Instead of allowing these bonds to space out, which would be a triangle shape, that is instead forcing this triangle down into this base of 3. Look at the Lewis structure of water that has a chemical formula of H2O, and this is the Lewis structure, the 2 versions down here. So in this you can see there is an oxygen with 2 bonds and 2 lone pairs. Okay, so first let's make sure that that is the correct Lewis structure. So that this central oxygen has 8 electrons around it. And that is why it formed the bond, is that there's 1, 2, and then in this bond 3, 4, 5, 6, 7, 8 electrons, and so that oxygen obeys its octet green. For the hydrogen has the duet rule, and there are 1, 2, or for this one, circling them, 1, 2 electrons around each hydrogen, and those are in those bonds. So hydrogen obeys the duet rule, and it needs 2 electrons to become stable. So these are overlapping circles, and those overlapping circles means that these are shared electrons, and those are covalent bonds. Back to the Lewis structure for the water molecule, you first choose the central atom. So this is the central atom, the oxygen. And on that central atom, there are 2 bonds. So that's 1, 2. And there are 2 lone pairs. 3. So this has 2 bonds and 2 lone pairs. And those 2 bonds and 2 lone pairs add up to the shape that's called bent, or V-shaped. And so this is because of those lone pair electrons, 1, 2, 3, 4, they're actually not spaced top and bottom. They're not spaced to give this, which would be all in one line. This would be a linear shape if it's drawn 2-dimensional. But what happens is that those lone pairs that aren't pictured in the 3-dimensional VSEPR shape, the molecule shape, they actually push downward the bonds, shown in green, which do appear in the molecule, though the lone pairs do not appear in the overall 3-dimensional shape. This is the overall 3D bent or V shape. And so those lone pairs have an effect. They basically take up more space in VSEPR theory. And they require more space and push the bonds out of the way, causing both the trigonal pyramid shape and also the bent shape.